So, hi everyone. You're welcome to our recap. It will be a two-part series, and we have the first part series here. We will talk about certain services, certain announcements that came out of reInvent 2025. We'll do that brief introduction, and then we are going to go. So, from my screen here, I'm just going to go with who I see. I see Rola. Can you just briefly introduce yourself?
Yeah. Hi, I'm Rola Dali. I'm a machine learning architect. I'm also an AWS hero and user group lead in Montreal and an ambassador.
Thanks, Darryl.
So, hello everyone. I'm a principal cloud solutions architect at Sienna in the telecom equipment space. I've been an AWS community builder for about a year and worked my way through many different parts of the development landscape over the years. And today I'm going to talk about durable Lambda functions.
Okay, thanks. Virginie, can you?
Hi, I'm Virginie. I'm French. Sorry for my English. I'm doing AI. I started AI 23 years ago, before a lot before ChatGPT, and I will speak about S3 vectors. I'm a AWS machine learning hero.
Okay, Sam.
Hi everyone, my name's Sam. I'm based in Portugal. I'm a serverless solution architect working for Serverless Guru. I've joined the AWS Community Builder program for the first year this year. Attended my first reInvent, so it's been a very exciting time. And I'm going to be talking about some of the cost-saving options for Lambda managed instances and database saving plans.
Okay, Ewere.
Hello, hi. My name is Ewere from Lagos, Nigeria. Just a community hero in Africa and also in Nigeria. I've been in Hero since 2019 and focused on DevOps and containers, but I'm an AWS community hero. This is my second event, and it was an interesting moment to join other heroes and also follow community leaders and user group leaders to um, share and learn from the announcements and keynotes about all the things.
Okay, thanks so much, Ewere. Thanks everyone. So, just a brief recap about reInvent 2025. So, reInvent 2025 had about 60,000 attendees, and I think that's the number that we usually have most of the time at reInvent, except when there was a pandemic. But it's usually one of the biggest cloud events. So with reInvent online as well, about 2 million viewers viewing from different countries. There are so many sessions. We usually get lost which session to join. About 3,500 sessions with about 3,000 speakers is really a huge event. We usually have pre-reInvent updates before reInvent, like a few months before reInvent. So this year we had 414 updates. And on reInvent itself, that's the reInvent conference itself, which was from 1st of December to 5th, we had 116 reInvent announcements. And here we have people who attended reInvent this year, and right from the source, they have key announcements that they want to talk about. Each person wants to talk about one thing that was very captivating during this reInvent. So we are just going to go with the first. Darryl, I would love to hear about Lambda durable functions. So you can take it away.
Sure. Just give me 1 second here to get the right screen to share. I'm just going to move this out of the way. Okay. Thank you everybody for attending. And as Cyril said, I was able to attend reInvent this year. For me, it was my first time attending, and it was had a really amazing time. The biggest thing for me was meeting so many people from the community, from the community builders group, the AWS Heroes group, and also many people from AWS. I'd met some of them before, but it was great to see everybody in person. So one thing that really struck me as a really important announcement during reInvent, and it wasn't actually a pre-invent, it was actually announced during reInvent, was the announcement of Lambda durable functions. So that's what I'm going to talk a little bit about today. So I already kind of introduced myself, but this is just a little bit more about my history. I've kind of worked in all the various parts of the development space over the years. The last few years, I've been focusing on serverless computing, containers, FinOps, all that kind of stuff. A wide range, and I'm always learning about new things and hopefully sharing most of the things that I learn with the rest of the community. So today I'm going to talk a little bit about, like I said, Lambda durable functions. We all probably on the call know about Lambda functions, serverless compute, being able to run your business logic in an environment where AWS takes care of all of the compute and management of all that, and we can just focus on our actual business logic. So with the announcement of durable Lambda functions, though, we have a lot more possibilities of what we can do with respect to workflow management. There's a lot of business use cases where you need to have more than just one set of business logic, and you need to involve different external systems and potential things like human intervention and stuff like that. So typically, this has all been done using tools like AWS step functions, which I really like using. But it's great now that we have a different option that we don't have to involve step functions if we don't want to, and we don't have to deal with messy things like Amazon states language, which I really don't like very much and have wasted many hours of my life debugging. So I'm just going to switch to the next one here. We're just talking about what Lambda offers by default without the durable functionality. So we all know and have heard about the 15-minute execution timeout. So basically a Lambda can execute for 15 minutes, and then after that you either have to have another Lambda and continue your operation. If you want to store state, Lambda is basically stateless by design. So if you want to store state of what you're doing, you have to use some kind of external mechanism like a DynamoDB table or other SQS and such to be able to handle state across multiple executions. You have to implement your own retry logic. If you need orchestration, you have to involve other tools. So for a lot of these reasons, for cases where you need to have a workflow type operation, the introduction of durable functions will help. So what are durable functions? Well, durable functions are regular Lambda functions, but with some code mechanisms on top of them where you can save state of an execution and replay or retry it based on whether things failed or whether you're waiting for something else. And the good thing is that you can write everything in whatever programming language you're familiar with. So right now, durable functions only supports Python and TypeScript and JavaScript. I'm assuming in the future they'll support more. But being able to write everything for your whole workflow in this language, as opposed to having to deal with various languages in addition to using Amazon states language in step functions, I think is a real advantage. One of the selling points is that you can run your durable Lambda function for up to 1 year. I'm not sure if I know of many cases where it would really make sense to run for a year, but being able to run longer than 15 minutes is a real advantage. You can basically have a durable execution that spans many Lambda invocations that add up to a whole year, which is a really interesting solution, I think. There's a quote here from AJ Stoyenberg about how it's basically just very similar to step functions like you already know, but you can code it all in your own programming language instead of YAML and JSON. So I really think that that's a big advantage. So here's a diagram. This is from the AWS documentation, just kind of a flow of how the invocation of a durable function goes. You basically have checkpoints or durable operations within your Lambda function that are coded in your favorite programming language. And then as each state progresses, a checkpoint is made to store the output of that state, or that step, sorry. And then in the example here in the middle, they have a case where one of the states is a wait state where you just wait for a period of time, so a number of seconds. So when the execution of the durable Lambda function hits the wait state, the output of the first step is saved, and then the execution of the Lambda stops at the wait state. And at that point, you're not paying anymore for Lambda compute because it's not actually running. But then when the timer in this particular case is done, the execution starts again at the beginning, but it knows that, hey, this is based on the identifier that you use, it knows that this is a continuation of a previous step, and it basically replays the output of the value from the previous iteration and then continues on with the next state. So basically, you can one at a time step through your code, depending on whether or not you're waiting for something from an external source or a callback, or you have a retry situation where some API you called is no longer, or sorry, returned an error, and then eventually it works. All of this can be handled in one block of code in your Lambda function, which is really nice. Sorry. Okay. Here's a list of the various durable operations, basically things that can be checkpointed and replayed. So as I showed earlier, there's steps, which is probably the most basic one. You can wait for a period of time, depending on some business use cases. There may be just a case where you always have to wait, I don't know, a minute or 2 minutes or an hour or whatever. Callbacks, which is very similar to what you have with step functions. I've used that in step functions all the time, where you get an identifier basically, and then you have a different part of your system that when it's done processing whatever needs to be done, it makes a callback to the API, and then the step function continues. Well, the same kind of thing can be done with the durable Lambda functions. Parallel and map states, these are useful when you have a whole bunch of smaller items that need to be handled. This allows you to iterate over those and in one block of code in the durable Lambda function, be able to handle all of this. Wait for condition is an approach where you can basically be polling for some kind of external entity to be in a certain state. And then run in child context and invoke. I haven't really spent too much time playing with those yet, but there's many different possible durable operations where you can where the Lambda will save the state of the outcome of the step or of the operation and then allow you to replay later. So here's a code example. I think it works, but it's maybe needs to be a little bit more complete. I just wanted to fit it on a slide. So in this example, it's an order processing system. The code looks very simple. I don't actually have the implementation for the actual validate the steps in here, but the idea is that this is an order processing system where you have to run through a workflow, in this case, validating an order, charging the payment, and then waiting for approval. So I think the third step here is kind of the key of where something like durable function shines, because in this case, in this particular use case, a manual intervention is required by somebody. They have to actually approve the order. Now, this may not make sense in modern systems, like, I don't know, if you're buying on Amazon.com or something, I'm pretty sure nobody actually approves it. But in some systems, you probably have this in an enterprise environment where somebody has to approve something. So the idea is that the third step, approval, wait for callback, this executes and it generates an identifier, and then you would basically pass that identifier off to whichever system will be responsible, like a front end where somebody has to click on a button saying I approve or something like that. But basically the durable function pauses and the state of step 1 and step 2 are saved when the pause happens waiting for the approval. And then when the approval is received via the callback, it continues, but it doesn't actually rerun the validate and the charge payment steps. It just uses the output of those from the previous iteration. And then the ship order state completes out only after the manual approval is done. Okay, I think there's many ideal use cases for this. Of course, everything that you can do with this, I think you can do with step functions or with other tools like temporal or restate. But I think there's a lot of advantages of being able to do this all in one place in one block of code. So order processing, like I just showed you an example of, human in the loop, there's many cases where somebody has to approve something or check for stock or something like that. I think using durable functions is great in those cases. And of course, one of the big ones these days is AI and agentic workflows, where you're calling out to a Bedrock or some other model where you're going to get throttled quite often, and being able to deal with those retries in code is kind of messy. So being able to put that in your Lambda function, I think, is a real advantage. So I haven't actually explored that angle with durable functions yet, but I plan to. Payment processing is another one. I think there's still a place for using other tools. I think it depends on the situation, just like anything in software architecture, it depends. I think step functions are great. They provide good visualization of the flow. They have the graphical builder, which allows you to build your step function workflows, which once I started using that, I basically got my hand washed of all of the trials and tribulations of dealing with Amazon State Language. I try to always use the graphical builder, but I'm not really the kind of person that likes to use graphical builders for anything. I like to be able to do everything in code. So the idea that I can, in many cases at least, switch to using Lambda durable functions, I think will be what I'll choose. But step functions have their place. And I have used temporal and restate in the past. I don't really like temporal in the sense that you have to, if you use their cloud offering, you have to pay a pretty large minimal fee, or you have to self-host it, which I kind of want to get away from in running in a managed and serverless environment. I don't really like having to self-host and deal with things like that. So some of the concerns that I have right now, and one of these was actually alleviated yesterday, because when they launched it, they actually only had it supported in US East 2, which was kind of strange that they would release something that was only supported in one region. But I saw last night that they announced that it's now supported in 3 or 4 more regions. So at least we're getting a little bit more support, although it's still pretty limited compared to the entire set of regions AWS offers. So it was only offered in US East 2 until yesterday, but now it's in 3 or 4 more regions. So And of course, it only supports Python and JavaScript, TypeScript. So I like to code in other languages like Rust and Go and stuff like that. So hopefully it'll be implemented. The SDKs will be implemented for those as well going forward. The visualizations, I have a demo, but we don't have that much time. So the visualizations I find aren't really they're as good as step functions. I really like the visualizations in step functions. So it does have good observability, but I find it a little bit confusing to try to follow coming from the step function side. And one thing that they mentioned about the 1-year timeouts, of course, it isn't obvious to many people that if you're making synchronous calls to Lambda, which maybe isn't the most common approach, but when you make synchronous calls, you're still limited to the 15-minute timeout, even with the durable functions. Like you don't get the whole year. The 1-year timeout is async invocations, which is probably the most common case for Lambda, I think, for most businesses. And it doesn't support, as some people pointed out, it doesn't support Lambda destinations for failures. It supports dead letter queues, but I'm assuming some of these things, maybe they'll support them over time. But these are some of the limitations for now. And just key takeaways, I think it's a really important advancement for the things you can do with Lambda. Always like having more choices to do everything. Like, yes, you can do everything in step functions or with third-party tools, but being able to do this in Lambda, which is one of my favorite services, and probably for many people that are doing service development is their favorite service as well. It's great to have the option. It does seem cheaper, but I haven't really done enough with it yet to estimate the real savings, because the state transitions in step functions can really add up, and the state transitions in this particular offering are quite cheap. Like I think they claim like 10% of the cost, but then you still have to pay for the Lambda execution on top of that. So I haven't really done enough to understand how much cheaper it really is. So I think that's the end of what I was going to show. So I don't know if there's any questions, or if you're going to do questions at the end, Cyril.
Okay, thanks, Darryl, for sharing. Sam, you can go ahead.
Perfect. Thank you, Cyril, and thanks, Darryl. Super useful, and somewhat relates to my talk, I guess. The other big announcement that came from Lambda as well. So just set up my screen. Okay, so my turn, round two. So got back. This is like a 10-minute lightning talk, and what I want to try and do is show how with sort of minimal effort, there's AWS have provided the opportunity to really slash your cloud bill, especially for your compute if you're running Lambda, and for databases. And although lots of the big announcements, for example, the durable functions, they're great new features or new products that are exciting to go and play with. I get most excited when an announcement comes out that doesn't really take much work to implement and switch on. And what I'm going to show you in the next 10 minutes is exactly that. So sort of keep that in mind. I'm going to really try and emphasize how you can take what you're going to learn in 10 minutes, take it to your job, to your enterprise, and try and implement what I'm going to show you. And you may see a huge reduction in your cloud bill and make somebody that's paying for it very, very happy. So we're going to start off with the database saving plans announcement from AWS. So when I saw that database saving plans were announced for AWS, for a moment I thought to myself, I'm pretty sure you already have database saving plans. So I went and did some research, and then I realized I was mixing up database saving plans with reserved instances for RDS and Aurora. So I had to do a little bit of digging to figure out the pros and the cons. I had a chat with a few guys from AWS when I was at reInvent. And sort of the gist of what I got is they think that reserved instances are a little bit restrictive. So the sort of the behavior of reserved instances is you're locked into a particular family of an instance. So this applied on compute, also applied on databases. And AWS, they don't want to lock you into anything. In case you haven't noticed, when they bring out new generations of particular instances, they tend to make them even more competitively priced so that you move to the newer hardware, because it's always been their ethos to make your cloud bill as small as possible to help retain your business. I really wish the rest of the world would adopt that ethos and try to make things as cheap as possible to retain your business. It seems to feel like the opposite most of the time. So they decided, I think it was 2021, they announced compute savings plans, and this year we've got database savings plans. And so there are a few key differences between this and reserved instances. First of all is the amount of services that are supported for savings plans. So as I mentioned before, reserved instances, it was really just for RDS and provisioned Aurora, where you're choosing an instance size. And a lot of the database storage options nowadays are these more managed services like DynamoDB, for example, and even Aurora Serverless. And you normally had an on-demand pricing and then provisioned. So with those provision pricings, you're giving a little bit of a commitment to AWS to say, hey, I'm going to consume this amount of reads and writes, so give me a small discount. And you would typically get a small discount. But now we can take things one step further and say to AWS, hey, for my database layer across my whole account or my whole organization, I'm going to commit to spending something like $10,000 or $100,000. And as a result, AWS, they're going to give you a fairly sizable and noticeable amount of savings. So I've been through the documentation to fully understand where these savings apply, where they don't apply, what services it impacts better and worse. I made just a very quick graph, nothing special. So I just want to go through some of the key ones, probably the most typical databases that you'd be using. So this purple bar here is sort of our comparison. So using the existing RDS and Aurora reserved instances, specifically using the X2G instance type, because that's the one that had been built and tailored for optimized database hosting. So again, AWS, they always want you to use the best hardware available. And so that's where they offered the best reserve instance saving. And so you'd get a 35% saving compared to the on-demand pricing. Now, that's 35%. And what I've done with the reserved instances is there are more options for reserved instances. So for example, you can choose to pay for your whole reserved instance upfront, and you would get even more aggressive cost savings. You can commit to 1 year or 3 years. So the longer you commit, again, the more aggressive it gets. And so I can see that this bar can actually go up to 46% if you choose the most aggressive options. But I'm going to choose what I've chosen here because it best reflects database saving plans. So I've got an AWS account here. If I just refresh, make sure I'm logged in. Yep. This is just my personal account. There's nothing really in there. Just to show you the options when you're purchasing a savings plan, I'm inside the billing and cost management console. You'll notice now we've got these database savings plans as an option. So beforehand, it was really just Compute, EC2, maybe SageMaker, or maybe that was announced this year. I'm not too sure. And you'll notice you only have an option for 1 year. So the 3 years is grayed out. Maybe it's something that they're going to bring out one day to, again, give you more of an aggressive cost saving. Your hourly commitment, something like this, whatever it needs to be. And then you only have the option to pay incrementally. So it sort of becomes like a monthly subscription almost. Think of it that way. And so you can see here, these are all the different options that we've got. So RDS and Aurora on demand, which is the best comparison that we've got between reserved instances. You'll see you only save 20%. So 20% still pretty good, but a nice take home for you. If you want to be very aggressive with your cost savings, the reserved instances will give you a cheaper bill. However, just remember what I said before, you're locked into these X2G instance types. You can't really move between them. You can stay within the family. I think you can combine sizes in some weird and wonderful ways, but it's a little bit restrictive, and AWS, they're trying to push us towards these database savings plans. You can see Aurora Serverless V2 has this ACU, this Aurora Compute Unit, and that gets 35%. So the biggest cost saving that I can see from the documentation is for Aurora Serverless V2. DSQL, announced last year, went GA a few months back, gives you 18%. DynamoDB on demand, read and writes, so your RCUs and WCUs give you about 18%, and then DynamoDB provisioned gives you slightly less. So I think that's 12%. And so the most important point here is to be, if you're going to go back to your business and say, hey, we're running DynamoDB, and I'm going to tell you how we can save 18% on our bill. It's not that simple. So what's important to remember is all these different pricing dimensions. And typically for these managed services, there's a compute cost, which are these silly units that they tend to like inventing, ACUs, DPUs, RCUs, WCUs, and so on. That's where you get your saving. It's the compute layer of these managed services. So if you have IO costs, for example, in Aurora, and the storage cost, which is you have storage in all your databases, that's still at full price. So when you go back to your company and try to do a little bit of FinOps, targeting that 18%, have a look at your database. If it's a DynamoDB that has a lot of storage, and that's where the majority of your cost is going, you won't get 18%. However, if it's got a lot of activity and actually you store a very small amount of data, maybe a few gigabytes, then maybe you will see closer to 18%. So that obviously doesn't require any kind of code change, deployment, or anything. You just purchase your savings plan here in the console, and then AWS will automatically apply those discounts on your next bill. So absolutely nothing that that your development team or engineering team needs to do. It's purely just a FinOps action in the console. Now, the second announcement is to do with Lambda and these Lambda managed instances. So previously, the hardware in which your Lambda functions were running was completely abstracted away from us. So it's obviously running on servers somewhere, but AWS is spinning those up, spinning them down, probably multi-tenant, I'd imagine. So you're sharing that compute with somebody else, I would guess, and you've got these tiny little Lambda execution environments. And they've decided to expand or reduce the amount of abstractness, I guess is a good word to use, and allow you to actually decide which kind of EC2 instances you want to run on. And so this can obviously come with a lot of cost savings as well, which is why I've linked it with the database savings plan announcements. Just going through the announcement blog here, you can see that we had, you provide a capacity provider. So capacity provider, you choose the kind of instances, EC2 instances that you want, your kind of architectures and so on. Then there's a few more bells and whistles that you can tweak. And then you just provide that as an input when you're defining a Lambda function. So instead of running on this completely AWS managed set of hardware, it's actually sort of running on your own EC2 instances. And so why would you want to do it? So first of all, if you're running Lambda functions at scale and it's fairly predictable throughput, that's a really important point. I think they even mention it, maybe it's in this doc or maybe it was another one. If you're running at high throughput, where you're going to utilize a lot of that EC2 instance and it's not going to be there sat idle. And if you're running at something that's predictable, because if you're running on these EC2 instances, they need to scale with your load. And we know Lambda scales really well. And if your EC2 instance can't keep up, it becomes a new bottleneck. So sort of that take-home message for the managed Lambda instances, and whether they're for you, do you have predictable high throughput traffic? If your Lambdas are ever sat idle for some reason, maybe you have spikes at 9 a.m. and 6 p.m., but nothing during the day, then you're going to be deploying those EC2 instances and just paying for them with no utilization. So just talking a little bit about how the pricing works. Did I have the pricing here? I didn't. That's okay. So essentially with Lambda, you pay for your requests, then you pay for your duration. And that duration pricing dimension has been now replaced by the EC2 instance that you deploy, plus a 15% sort of maintenance fee for AWS to patch it, to run. There's obviously some Lambda software that's running on it to host all these small containers. And so that is now your new cost metric. So you need to decide whether that duration metric is worth switching to an EC2 instance metric. Now, the other reason that it could be quite useful is what I'm showing here on the screen here. Now, because you're running in your own instances, there's no issue with sort of this noisy neighbor problem. So AWS is now going to let you do a little bit more tweaking. So they'll now let you choose the ratio of your CPU to memory, which can be very useful in certain scenarios. Just a reminder here of how the typical vanilla Lambda function looks. I couldn't find it on the AWS docs, but you'll see normally as you provision more memory, AWS will then give you more and more cores. And it's fixed. It's a fixed kind of ratio. If you want to have more memory but just one core, you can't do that. But nowadays, that's exactly what you'll be able to do. So again, a little bit more tweaking, which may suit your use case. So I guess to conclude, database savings plans, absolutely no change or awareness needed from your engineering team. You will just simply see that reduction in your cloud bill. Managed instances, there'll be an infrastructure as code change because you have to create this capacity provider and then provide it as a Lambda configuration. But what's important is your actual application code itself. You look at what Darryl just showed us with durable functions. There is code changes needed to sort of implement all those steps. There's absolutely nothing needed from an application point of view here. So this is just infrastructure as code. You decide to just sort of move them to EC2 instances. They may perform better if you give them a better memory to CPU ratio. And then because you're running them on EC2s, you'll get the EC2 pricing, which will usually be more competitive than the Lambda duration metric. I think that covers everything, Cyril. Sorry, I went slightly over. I'm really excited for it. So take these two aspects back to your business and see how you may be able to implement them in a few weeks rather than a few months.
Yeah, this is interesting. Thanks so much. Do you have any questions for Sam?
I do, if I can ask. Sam, one of the things you showed there was the page on the Cost Explorer where you can look at the savings plans, and I've used that for purchasing EC2 savings plans and compute savings plans. One thing I've run into, though, is that whenever I try to do an analysis for database savings plans, it always tells me there's no recommendation, but we spend thousands and thousands on database savings plans. There has to be one. I'm not sure if you or anybody else has run into a problem that the analyzer doesn't really work very well.
No, so I can talk very quickly about what these two tools are. So we have the recommendations engine within the cost savings plan, where they've now added database savings. This will take your sort of previous usage. You can see here, you can base it on a X amount of days and so on, and then it'll provide some recommendations here. So I've got an empty account, so this won't do anything. I don't know. Maybe that's a bug. I'm not too sure. I haven't really got an environment where I'm running any kind of sizable workload on databases other than client work, but I don't have the IAM permissions to get anywhere near the billing console. So I've been able to play with this tool. Now they have added, along with the recommendations, they have the purchase analyzer as well. So I think this is brand new, even though they've incorporated the existing things like compute savings plans, but you can essentially do all the bells and whistles in here, and it will just give you a little bit more of an analysis into the overall cost savings, I think. There's a nice screenshot maybe in here. Here we go. So this is the purchase analyzer. So you can see here, it will kind of show you, they always teach you to try and, you want to get those aggressive cost savings, do that. That's kind of like a nice baseline. And then it's okay to overflow here in the pink in your on-demand. So sometimes your database is going to have to scale, but you don't want to provision for the peak. So provision for the trough, and then just eat up that on-demand pricing for the peak.
We've had cases where we overcommit to the savings plans and end up paying money for nothing, which is unfortunate. So you always have to make sure you try to have it where your minimum is. So
yeah, and what's good here is, if you remember, it includes all of these database services. So although many people aren't using TimeStream, for example, I love the fact that it combines DynamoDB, Aurora, DSQL. Although not too many people will be using that in production, Elasticache as well. So you may not fully utilize your compute, which is a shame. But there are lots of different kind of database layers, especially across big enterprises. So it reduces the risk by spreading out that costs. What's the word I'm looking for? That promise for paying to spread across multiple database solutions.
Okay, thanks. And if you have more questions, Sam is always available. So Virginie,
yes,
you can go ahead and share with us. Okay, we're excited.
Yeah. I will share my screen, hoping you will see it. Okay, I will speak about S3 vectors and how to save money, as it is the main topic, I think, this year. In a lot of cases, I see customers trying to do RAG, Retrieval Augmented Generation. That is to say, they are trying to use their documentation to put that in a vector database and then to be able to retrieve it. And in most cases, it costs a lot because you have to use Elasticsearch, OpenSearch, or another vector database. And so generally available since last week, there is S3 vectors. The preview started during the summer. So I don't know if some of you have tried it during the preview, but now it is available in 14 regions. And what it is, in fact, it is a S3 bucket type. In this bucket type, you can store vectors, but not only the vectors, but also metadata and the full text and so on about your vectors. So you have a full vector database in S3 with the price of S3. So you will have to pay for the storage, and you will have to pay for the read and write you're doing, but not for infrastructure. So you will not have to pay a server or anything like that, or a database or so on. And so it is very, very, very cheap. I've tried on some use cases. I have personal use cases, and it will divide the price by 100 for my use case. So it is really something to improve my FinOps on RAG. So it's very, very interesting. It will be very quick with a latency around 100 milliseconds for frequent queries. So very, very small latency. You can put a lot of vectors. You can put millions of vectors in it. So you have the choice to put nearly every vectors you have in the same bucket, and you can have many buckets, many S3 buckets if you want. It's just a bit more difficult to handle if you have many of them. But I think it's really a great thing to be able to create easily a RAG. And what is interesting also is that it is included in Bedrock. If you're trying to do a Bedrock knowledge base, that is to say a RAG, you will be able to choose S3 vector as the database. So if you want to use S3 vectors, you just have a choice using OpenSearch or S3 vectors or another database. So you will be able to use that starting right now. So I think it is very, very interesting to test, to do proof of concepts for RAGs. And if your RAG is going bigger, bigger, and bigger, maybe at one time it will be useful to go to another database. But I think with the prices of S3 vectors, you will be able to stay in S3 vectors a long time before needed to go to another database. So I think it's really good. And when I saw it, I was like, oh, I have so many customers who will use it. And it will be so useful for them to try things and just to test things without having to pay for a whole infrastructure for 24 hours a day. So it's great, I think. So I have also a blog post, so you can go to AWS news blog. The QR code is here if you want to go there. And so you will be able to find the news blog post. And in the news blog post that has been written by Sébastien, it is a friend of mine, a French AWS guy, very good. And its blog post is very good also because you will have a lot of information about how to create a S3 vector bucket, what you can do with it, and so on. So you can see every option that you will have. And so, yeah, if you need something, go there, look at that, and I hope you will be able to use it because it is very great. And you can also use the OpenSearch capabilities with the S3 vectors for the storage layer if you want. So in this case, you will have to pay for the OpenSearch infrastructure, but not for the storage. And you will be able to use the S3 vectors for the storage if you want to keep your application like they are right now if you're using OpenSearch. So a lot of things to do with it, I think, and a great one. But go there, try it, and do some RAG with it.
Yeah, thanks. That's nice.
I have one question. I know I really want to use this for almost everything. I think the concern with some people in the community is that it's too slow latency for some use cases. I'm curious what you think about that with respect to like some applications. It's just going to be too slow using S3. It's super cheap and very convenient, of course, though.
Yeah, they have done a lot of improvements on the general availability S3 vectors and the preview S3 vectors. So if it was too slow in the preview, maybe it will not be too slow for you in the general availability one because they improved a lot the latency. So now it is 100 milliseconds for frequent queries and 1 second for infrequent queries. So of course, in some cases, 1 second is too long, and you cannot wait that time. But if you're working with humans, in most cases for humans, it will be sufficient. So I think you have to try. And if you tried the preview one, try the new one with the improvements, because maybe the slow thing is not the thing anymore. And so you can just have something, a loader or thing like that saying, oh, we are retrieving your documentation with a small word and so on. So during the time that you can proceed to read the sentence, the work will be done. So you will have the results.
Thank you very much.
Ewere? Yes, can you tell us a bit more about the DevOps agents?
Okay, hello everyone. Introduced myself before. I'm Ewere, an AWS hero from Lagos, Nigeria. So I'm going to be talking about AWS DevOps agents, which is currently in preview and was announced at the event. So basically, AWS DevOps agent is a frontier agent. So frontier agents are special kind of agents designed for specific purposes, different from the common agents where you have to do some extra work. So you have basically some major frontier agents that AWS launched during the reInvent. One of them is also the security agent, which I won't be talking much about, but I'm focusing more on the DevOps agent. So this is a frontier agent that is designed like an autonomous on-call engineer that accelerates incident response and improves system reliability by analyzing operational data and past incident patterns. So basically, from the DevOps perspective, what this really means is that you have like an on-call engineer that serves as an agent. Most times when an incident occurs, there are so many processes you have to do. First of all, you have to analyze the incident. You have to know what's happened. And most likely the level of incident, if it is a critical, medium, or low incident, before you actually trigger an incident and triage on that incident. What AWS is telling us here is that instead of an individual having to perform those operations and determine all those things, you have an agent that sits in between, helping you to analyze all this information, because you really have to analyze the failure in the system to be able to determine what type of incident it is. And it also does that using past incident that has happened and past incident patterns, which is also, the tenets of what machine learning and ML is all about. So it uses past data to determine what you should call an incident or not. But the goal of this is that aim to shift things from reactive firefighting to proactive reliability improvements, helping reduce one of the major metrics of system reliability and SRE called mean time to resolution or mean time to recover, MTTR. So what this does is that it's able to more or less predict. So predictions in AI have gone beyond just number prediction. Okay, from this you can actually predict an incident. So based on certain things. So for example, you have experienced some incidents of certain downtime, maybe related to some RCAs like memory issues, disk issues, or traffic issues. So DevOps agent is sitting in between your system to be able to analyze this data as it's coming into it and able to tell you know what, in another 30 minutes, in another 1 hour, if you don't expand, let's say your database disk space, there's a possibility of a downtime. So the agent brings AI-driven autonomy to DevOps operations, making incident response faster and less error-prone, more systematic than manual processes. So before now, if you want to do this, you need to have someone who is sitting down to ensure that this is fixed. And as an agent, one of the core tenets or features of an agent is not just to analyze, but also to take action on your behalf or take decisions based on your behalf. So this sits in between as an autonomous agent. Now, another thing it also does for you, the DevOps agent, is that it serves as an incident investigation and root cause analysis. So once an alert or incident ticket comes in, the DevOps agent automatically initiates investigations by correlating logs, metrics, recent deployments, traces, and other telemetry. Now, before now, all these are something I practically do manually. Okay. At the moment, if I want to trace something that happened, I check like my releases and my deployments that happened, tracking in via error tracking tools like Sentry. And then I go back to my Grafana dashboard to check my logs when it happened. I check my metrics also in Grafana from Prometheus source to see, okay, when did this happen? Was there a spike? Was there a memory issue? Is there a bug? These things are correlated manually. The best you have for now before the DevOps agent AWS had was correlating logs, traces, and metrics into this single pane of dashboard to analyze the pattern or the trend that happens. Now you have to use your eyes to analyze this, and sometimes it takes some time and you can make mistakes. But having the DevOps agent sitting in between this makes it much easier and faster. Now, the DevOps agent integrates with observability deployment tools like CloudWatch, Datadog, Dynatrace, New Relic, Splunk, GitHub, GitLab to build a comprehensive context for issues. So imagine being able to build the context of an incident or an issue right from when the developer pushed the code from deployment down to the errors the user or the customer is having on production environments. Having to correlate all this data right now is next to impossible because you have to build a lot of systems in between. And what we usually use as DevOps engineers is we use just what we have on the observability platform to know what is going on. We barely look at the code changes. DevOps agent is here to sit from the code change down to the production deployment. That means it's seeing everything end to end. Now, the agent identifies probable root causes and outlines findings, reducing the time engineers spend manually piecing together evidence, which is what I mentioned. So most times you have to sit down and look at the logs. Okay, when did this happen in the logs? Even if you get an alert for it, you have to go back to the logs to view the logs. You have to maybe correlate this with traces. So even if you have traces, which could also even complicate how you debug, because traces show you the journey from start to finish of a single transaction. Okay, you can see where it is failing, but you can see that it is failing, but you might not even know what exactly is causing this failure. But with this agent, it acts like an always-on SRE assistant and removes guesswork from investigations. That's exactly what it does for you. It saves you a lot of time. And then lastly, one of the things that I love about it is that the adoption is pretty easy, okay? You see that I mentioned already industry standard observability systems and deployment systems like New Relic, like Grafana, like Splunk, like GitLab, like GitHub, which are systems we mostly use for build and deployment operations. Now, the easy adoption with existing toolchains. AWS DevOps Tool Agent is built to work with existing setups, connecting via the AWS console and integrating with third-party monitoring, CI/CD ticketing tools you already use. So tools like I already mentioned before now, we use logical boundaries called agent spaces. So this is how it's able to separate different kind of agents within the console, to group what the agent can see and act on, making it flexible for different team structures and environments. So it can actually analyze the issue and tell you this is what the issue is, and you can actually tell it to fix it or you fix it yourself. Custom integrations can be added via MCP. I'm sure we know the MCP protocol, Modest Context Protocol, okay, allowing support for proprietary tools like Grafana or Prometheus. So it means that if you see that the DevOps agent does not support your existing system or the systems you use, you could actually build, either you use an existing MCP from, a secured MCP registry like Docker registry. Okay, please don't just download any MCP server from the internet. So you don't download something buggy or something that has some security flaws. So you can download an MCP and integrate MCP servers with the DevOps agent, which gives you the ability to call tools within your systems and perform actions based on the data it has collected and analyzed. So teams don't need to overhaul their DevOps tool chain. So you don't need to figure out how you want to change your tools. Maybe if you use Grafana at the moment and Prometheus like I do, and you want to change to Splunk because you feel DevOps agent has native integration for that, you could actually use MCP as your binder between your existing systems and the DevOps agent to benefit from the autonomous incident response. So this is a summary of what the DevOps agent can do and what it can be used for and how it can actually improve your delivery as a company and also your system reliability, because system reliability and uptime is key to every business. So having to save you time in ensuring that your MTTR metrics, which is your mean time to recover metrics, are actually top notch, and having to reduce manual labor in terms of analyzing metrics, logs, traces to figure out the root cause of a problem and then fix it is actually the major goal of the AWS DevOps agents. Thank you. Hope I'm within time and I was not too fast.
Thanks. I know it's not easy. There are lots of interesting things to speak, and 10 minutes is also part of the challenge. But thanks so much. So, Rola, I would want you to tell us what actually Werner was saying we need to do this year. He's always having something to say.
Yeah, so I'm going to talk about Vogels' keynote, which was interesting to me for several reasons. One, it is his last keynote. He made the announcement that after 14 years of this is the 14th reInvent, and he's done 14 keynotes. He will no longer be doing them. He said he's not leaving Amazon, but or AWS, he's opening space for new voices, which I am very sad about. Vogel's keynotes is one of the things that I've personally enjoyed year after year. He usually does a really good job of taking something that's pivotal in the market, that's very relevant, and then distilling it into a really good message. And I've enjoyed every one. And so this year it's been about the Renaissance developer. And this is interesting because as we've seen AI get better and better, and there's a lot of fears about how it's going to change the job market, and is it coming for my job, and what do I need to be learning, and how do I need to be evolving. And so he gave this really good keynote, I think, that was very grounded, and I think everybody should watch it. So it's very interesting that we can see that they've made these really nice images about the Vitruvian Man in modern times, where a developer does, I guess, now codes in their pajamas at home with remote work with their little slippers and so on. But Vogels gave us an idea of, so he started his talk by saying, will AI take my job? Maybe it could take your job, right? Depending on what your job is and whatnot. Will it make you obsolete? That's probably not true. And he went through the timeline of how when assemblers came out, it was very cool. And then when compilers came out, the assembler people were scared. And then when the higher levels languages came out, every new invention, I think, causes some sort of fear. And I had read a book about how electricity kind of also, every technology in a sense creates a lot of fear about how change will happen and how the world would change. And so Vogel's idea about a Renaissance developer is that the craft is changing, for sure. Software is changing. Everything is changing in some way. But humans themselves will not be obsolete. And to be a developer in the Renaissance age, in our age, requires a few characteristics that will make people successful. And here's a list of what he thinks is important. So the Renaissance developer is curious, right? You have to experiment, be willing to fail, try different things. We are not what we know, but what we're willing to learn. Where you should be always open to learning, to expanding who you are, what you know. The Renaissance developer thinks in systems. So AI, I think, is making it really easy for anyone to code. English is the new programming language. And so there's going to be less concern about syntax and language, tiny language issues. You have to succeed, you have to be able to think at a higher cognitive level, right? How do you architect a system? How do you design a system? How do you, not really about how do you code it up anymore, because that's becoming less of an issue. And so you should be able to teach yourself how to see the bigger picture. How do you design? How do you architect? And how do you implement successfully with using these AI agents as help? The Renaissance developer is able to communicate. And he made the point that we need to be able to communicate both human to human and human to machine, right? We used to be able to communicate human to human with natural language, human to machine with coding languages. Today we can, in theory, communicate with both machines and humans with human language. But the idea is that you have to be able to communicate what matters And I think this is always an issue in that developers and engineers are not known to be the most expressive type, I think. So taking an idea and transmitting it to another human or to a machine in the most concise and efficient way is going to become, and has always been important, but I think it's going to become more important. And the Renaissance developer is an owner. So you have to have pride in your work. You have to own the quality of your work. The system is yours. You build it, you own it. It's not the machines. The machine can help you with, and it's going to help us more and more, but humans have to take ownership over their systems and things they build. And then the Renaissance developer is a polymath. So you need to be able to have a wider understanding. And this is, I don't know if you know the knowledge shape curve, where if you can be an I, so that's somebody who's very deep in one thing, but only knows that one thing. And you can be someone who's broad, so a T. So the idea is that you broaden your understanding. You're an expert in one thing, but you can manage your skill set in a lot of other things. And this has become more and more important, not only because of AI, but because of the diversification of being able to talk to your DevOps team and being able to talk to your product team and everybody who's now part of software. You need to have that basic skill set to communicate with everybody. So that's his those are the things that he thought is important. This also resonated with something that I had read, that I had watched from Andrei Karpathy, which I really respect quite a bit. And he gave this talk at the Y Combinator titled Software is Changing Again. And I found this very interesting. I have a link at the end where he practically said that, software had been stable for around 70 years or so. And then in the last 10 years or so, we saw 3 major pivots in software. So software 1.0 was computer programming. If you wanted to develop, to create something that, for example, classified an emotion, you would say, if you're reading in Python, you would define a function, you would create that function, and you would set a bunch of rules of how that system would work. In software 2.0 was machine learning, right? With the deep learning boom that we saw, instead of codifying rules, you gave machines an input and an output, and they figured out what the patterns are. And now what they're calling it software 3.0, which is an LLM, right? You speak to it in English and it can bring output. And as we've seen this shift in software, as a young software engineer coming into the market, you should have an understanding of all 3 paradigms of how software works and how things can work. And so you can create the same exact function in those 3 paradigms with various trade-offs. And so I get asked by a lot of younger people that I mentor, should we learn computer science in the time of AI? And my answer is always yes. There are going to be changes, like everything. But as Werner put it last week, just keep calm and carry on coding, right? Just learn, broaden yourself. You have to pivot. You have to understand what's happening. We're going to code differently, I think, but I don't see us becoming obsolete anytime soon. So that's my message. And I've got the QR codes for Werner's keynote, which I think it resonated with me, and I think it's useful. And Karpathy's talk, which I also found very, very insightful. And they also gave this kernel, this tiny newspaper sort of thing, with some really interesting articles if you're interested in looking at that.
Okay, thanks so much. That is the energizing part of the Reinvent, and you also energize the meetup as well. So thanks so much for all your contributions. This is really rich, and I'm sure there'll be so many people who are going to benefit from your rich and very, very generous sharing of knowledge. Thanks so much. Thanks, Sam. Thanks, Virginie. Thanks, Darryl. Thanks, Rola. Thanks, Ewere. We hope to have you all maybe next year when you deep dive into each of your sessions with more demos and let's see how to build. Thanks
very
everyone.
much, Cyril. Thanks, everybody.
Thanks for having me.
Thank you.
Thanks. Yeah.
Bye. Bye, everyone.
Bye.
Bye.